ERC is standard of Ethereum request for comments, and those are mainly application level. That means that are standards for smart contracts layer of Ethereum. There's also the EIPs, which are the Ethereum Improvement Proposal, but those are mostly for the protocol level. ERC are mainly for application level standards. So you can check Ethereum websites, EIPs, and /ERC. You will see all the application level standards. The first one is token standard, it's 20. It's important and was made by Ian, and Vitaly Buterin. There's a lot more. You can check the website. It's interesting to see all the protocol, all the standards that are there. So, what is a token in the context of blockchain? Mainly are assets that allow information and value to be transferred from one address to other address. And because they are on the blockchain, those are transferred, stored, and verified in an efficient, secure manner. Yeah, they can be like, they can have like different characteristics depending on the type of token we will see later. So it's a standard in the context of software. It's mainly you can like copy pasted this from Wikipedia. Mainly it's some common agreement of some document file, whatever that's used in software development for making that piece of software document be reusable by other software. So that's why we are building a wallets, and there are many wallets in the market, and they can interact with the same smart contracts. That is because there are some standards out there that complies with those standards, and the wallets are knows how to toggle with those pieces of software. So in the what is a token standard is mainly it's a set of specific rules and protocols that determine the way a cryptocurrency token security behaves and functions on a blockchain network. That means how smart contracts, how is the smart contract supposed to be for token. So in this presentation, I will cover the three main tokens that are mainly used in the ecosystem. I think this is the most important one. That is ERC20. That's mainly the standard for fungible tokens. Fungibility, I think you asked me yesterday what's fungibility. It's an economics concept, which is basically the property of an asset to be interchangeable, but also indistinguishable from one unit to other unit. So, for example, we have a 10 euros bill and other 10 euros bill, the same. What would you want? I have one. I have two here.
Can we get out?
No.
For demo.
Yeah, 10 euros is the same. It's the same.
Yeah.
The units have the same value.
Yes.
So in the context of blockchain, we have Ethereum. It's a fungible token, but it's not ERC20 because it's a native token of the network. But for example, SNT is an ERC20, DAI is an SNT. It's an ERC20, and we have many examples here. As ERC20 is a standard for smart contracts that defines how a token should be. These are some of the methods that the ERC20's contract should have to comply with that. So, for example, you have total supply, returns the total supply, balance of owner, is on the address, and it returns the balance of that address for that has some transfer functions, transfers token from one address from the sender address to the address, that parameter, and the value that is being sent. There are other methods such as transfer from. This is important, for example, when you work with swaps, because a swap would transfer tokens for you, behalf of you. But for that, you should allow, the sender should allow the smart contract has this approved contract, I think it is, approved method that allows the address or another address to send contracts send tokens on behalf of you. Some example tokens are USDT, SDT that is already mentioned. And this is an example, a solidity code example of an ERC2 smart contract. This is very simple because there are already companies that have these contracts already made, already audited, and as we are programming money, it's important that we create tokens are secure. So it's better to use some library that has their contract already audited. So we import this ERC20.sub is supposed to be contract, and for example, this is you deploy this example token. This is the name of the token. This is the symbol of the token, and it will meet to the sender. That is the address that deploys the contract, all the initial supply. So when you deploy this contract, the deployer will have all the supply in their wallets. That's for ERC20. Then we have ERC71, that is for non-fungible tokens. So mainly, like if we compare to ERC20, 721 are non-fungible. ERC20 are fungible tokens. We'll see how ERC71 makes non-fungible tokens. So you have our bunch of methods. It's balance of. You send the address, and it returns the balance, how many tokens and the address has of this contract. You can set the hour off, you send the token ID, and it returns the address that owns that token. Says transfer from transfer one token from one address to other address. Transfer from does the same, but without some safety checks. Then again, the approval mechanism that the ERC20 also had allows a given address to transfer a specific token to its owner. That could be for swapping NFTs. That could work for this kind of stuff. Let's get approved. Yeah, it's all functions for approval mechanism and getting the approvals and setting approvals. Yeah, so I mentioned we have the safe transfer form from. This has an additional parameter which is data. I don't know exactly what it does. I think it's it only is the only purpose of this data is to send an event to the blockchain, so you can provide an additional information of this transfer, but just for just for letting know an application what this transfer is happening, you can send a message, whatever. And that's really important because the token URI, this is not specifically in the ERC 721 standard, but there's a ERC 721 JSON schema optional extension. There's an extension of 721 that's mainly used. Most of the 721 tokens contracts has this token URI. That's for returning the metadata. The metadata is basically URI that points to the metadata, and it's basically what it makes a token has some specific properties. So what the heck is token? Let's see an example. As I said, the metadata is a detailed information that describes the specific attributes of the token. Mainly it's stored off-chain because in the blockchain we can't store big amounts of data because it would make it that's non-scalable. The importance of the metadata is that you can add attributes to each token. Like each token could have a name, a description, an image, whatever.
Go to the question. Is there standards for the metadata as well? Like
Yeah.
the structures? Okay.
Yeah. This is for the token, but there are some standards that are defined by mainly OpenSea and other NFT marketplaces.
Okay.
What is the blockchain? Where is it stored? Like provided?
You can store whatever you want. It's mainly like you can store like in AWS, or for example in IPFS storage, or if you want to make it more secure, you can use Codex storage. So this is an example of metadata. There's some standards for building the JSON specifically, but all the standards are very similar to this. It's a name, a description, an image, external URL, and attributes. Again, this is an example of ERC 721 smart contract. We import the extension ERC 721 extension. This extension specifically allows us to store a URI for a token. So it complies with the JSON extension I mentioned, and this ownable is basically to allow only the owner of the contract to call this function. This is only owner, so only the owner of the contract could call that. And this mint NFT, what basically does is minting a token and then set token URI for that token. So how could I mint an NFT with this smart contract? Basically, you would first need to deploy the smart contract on the blockchain. You can use any of those tools, Remix, Foundry, whatever. I won't explain this in this session because it will be too long. But yeah, you deploy the contract, then there's at that stage there's no tokens. You would upload an image to storage, whatever storage you decide to upload to. Then you create the JSON metadata, like you create this JSON. You point the image, you fill the image attribute with the URI. And then again, you upload the metadata to storage. Could be whatever storage you want to upload to. And when you have that, you can then interact with the smart contract by calling this mint NFT function, and you pass the receiver address for this new token and token ID. You can't repeat token ID because this standard only allows to have one of each tokens. That's because they are non-fungible. And you pass the token URI that points to that metadata. So this is this function. Some examples, CryptoKitties are mainly this is the app that permits you to create kitties, breed them, and each kitty has their own metadata. So maybe there are some kitties that are more unique or have some more unique properties than others. And yeah, have the CryptoPunks. It's just a bunch of 10,000 images, randomly generated images. Yeah, they have different properties, and each token has their own metadata that points to an image. That's for ERC-71. And lastly, what I will cover in this presentation is ERC-1135. It's multi-token standard. It's my personal perspective, is a better standard, but I think it's not that adopted as other standard. But it's used. It's mainly enables a single contract to have the possibility to represent different types of tokens. Fungible, non-fungible, semi-fungible could be. So it has some differences as ERC-71. You could transfer, have this function to make batch transfers that enables to optimize gas for the same for transferring multiple tokens. Yeah, you could get different balances of an owner of specific token IDs. Yeah, have this balance of, as this is an ERC-1135, the balance of could be the balance of ID could be more than one. In ERC-71, the balance is always one because tokens are unique. This is more flexible. Tokens could be unique, but they could not be unique as well. Then the transfer from functions. Again, the approval mechanisms. This will be important when we implement swaps or interact with other smart contracts that could make transfers on our behalf. This is the same. These safe features. Mainly, what they do is they check that the address you want to transfer from, if it's a wallet address of a person, it's okay. But it could be the case that the address is a contract, so that contract should comply with some specific functions. So the tokens, if you transfer, they don't get blocked in the contract, because if you use transfer from instead of safe transfer from, and the token and contract doesn't comply with those functions, the token could be locked forever in the contract. That will be very bad. Again, we have this URI to get the metadata for a specific token ID. This is the same as the ERC-71. Some examples. Engine is the company that created this standard, that proposed in the first place. It has a gaming ecosystem. The sandbox like a metaverse stuff. They use these lands. You could buy a land. The land isn't complies with this standard. Decentraland, another metaverse, adopts this standard for handling the items or themes for this virtual world. OpenSea also supports CRC 1135. If you use their smart contract, they have a free, like a gasless smart contract, and that is ERC 1135. So if you mint an NFT on OpenSea and then you check the contract on Etherscan, you will see that it's ERC compliant with its ERC 1135. Another example of ERC 1135, again, we import the token, the base contract from OpenSea package. And what this does in this case, in the constructor, you send the URI placeholder, which should be replaced depending on the token ID. You construct this token with the placeholder, and what it does this specifically is it deploys in the constructor. It deploys some gold, silver, sword, shield. Each token has their own name, but those are like different tokens inside the same contract. They have this is the balance, the supply, and I think I don't know what else, but I suppose it's some data or name, same name parameter. Then we have again this mint function. This is all the owner. We repeat the same pattern as ERC 71. We also extend for ownable, so that means we have this modifier function, and only the owner of this contract can call mint function. Since the ERC 1135, we also have a mint batch. You can mint multiple tokens with different IDs in the same transaction. So this is basically ERC 1135. It's more flexible. Chip.
Is 1155 only used as a replacement for 71 or also as a replacement for 20?
I haven't seen it used. I haven't seen it used for replacing ERC20, but it could be.
It can be.
It can be, yeah. It depends on the adoption, but I haven't seen ERC 1155 replacing an ERC20.
Something has like decimals definition, so you need to do everything with integer object, but you define decimals for ERC20 to have like comments. ERC never people try to have that as part of it. So it's not a direct replacement. Can't really be used to replace ERC20. But it can do, I would say, all that ERC71 can.
But why does it exist then? Is it special from 7 to 1? What else does it do?
I think it came afterwards, so it's a newer standard. So you could use it as a replacement for 71 and use a subset of what it's just some people who don't need to have this similar functionality capabilities.
Yeah. So for example, we have in this example we have gold, silver, different kind of items in the same contract. But for example, if you check CryptoPunks contract, there's only CryptoPunks there. In this contract, you do have CryptoPunks, kitties, like all in the same contract.
Thank you.
The gas fees is like improved in batching? Or?
Yeah.
Okay.
You can send multiple tokens in one batch, and that optimizes has probably that has another optimizations.
Okay.
I think that's it.
Nice.
Any other questions?
What are some is, I don't know, the owners of the limiters or whatever, the builders used to be sure that their URL for the metadata or for images in case of NFTs are long-lived. Are long-lived, like, I don't know, maybe the server, the domain can go off and the URL cannot be available.
I mean, it depends on the strategy of each developer, but mainly we could use solution like Codex that is available, or other competitors to Codex that will ensure long-living files. There's also, I personally use IPFS. That's more distributed, not decentralized. They can that image or metadata will live as long as there are people pinning those files. I'm sure there are more long-living type for those files, but that's not ensure many years.
So,
And they could be centralized also, like yeah.
The example you gave, like CryptoKitties, what do they do?
It's just centralized.
It's centralized.
Because they use breeding, so for breeding you should you can evolve the kitties so the metadata can change. So if it will be a permanent search, the metadata will change. So it depends on the strategy of the project. Any other question? Thank you.
Thanks, Brian.
Thank you.